Welcome to the Math Professors. We provide free videos pertaining to algebra, pre-calculus, statistics, calculus, and so on. So please consider liking, subscribing, and sharing so we can provide more free content for you. So today what I'm going to cover is the mean, the variance, and the standard deviation for a discrete probability distribution. So this kind of stuff you're going to see maybe in your first statistics class in college. So these are the formulas for finding your mean, variance, and standard deviation. Your mean is going to be the sum of x times p of x. Your variance is going to be the sum of x minus mu squared times p of x. And then the standard deviation is going to be the square root of that variance. So using a probability distribution, I want to be able to find the mean, the standard deviation, and then eventually the significantly low and high values. So we did this in a previous video, this particular probability distribution, and explain where these probabilities came from. But now I want to find their mean and the standard deviation. So this example pertains to the number of girls in 3 births. So, if I have a family of 3, I can have 0 girls, which means I have 2 boys. I could have 1 girl, which means I had a boy first and a girl second, or a girl first and a boy second. Or I could have all girls, which would be a girl first and a girl second. So then you can see that the probabilities would be, 1 out of 4, 2 out of 4, and then 1 out of 4, respectively. So if I want to find the mean number of girls, we kind of have an idea that I know the probability for having a girl is somewhere around 50%, and so in college we just always pretend it's 50% to try to make this the math a little bit easier. So what we can see is that I'm likely to have 1 girl is what is really the expected value for the number of girls for a family of 2. And what I want to do is I want to prove that to you. So in order to find the mean, what I have to do is I have to do the sum of x times p of x. So what I do is I just kind of build out this probability distribution table, and then I find a column that is x times p of x, and then eventually I'm going to take the sum of this column. So what I'm going to do is I'm going to multiply the first row, the first x times p of x, which is going to be 0, 0 times 0.25. 1 times 0.5 is going to be 0.5. And then 2 times 0.25 is also going to be equal to 0.5. So what I know is I know the mean is equal to the sum of x times p of x. So this mean is going to be, this 0 plus 0.5 plus 0.5, which is going to equal 1. So in this case, this represents girls. So where x is the number of girls. So I should say that this is the number of girls. That's your x. Okay, so now that I've found my mean, I can find my standard deviation. So what again, as I continue to build out this table. So before I can find the standard deviation, I have to find the variance first. So I need to sum all of these. So I'm going to do x minus mu squared times p of x. And this calculation is going to be a little more complicated. So I'm going to write them out and then we'll find these by hand. So for this first row, x is going to be 0. The mean is always going to be this 1 squared times p of x. Well, p of x for this row is 0.25. So now when I do this multiplication, negative 1 squared is 1 times 0.25 would give me 0.25. Next I have x is going to be 1 minus the mean, which is also 1 squared times this p of x, which is going to be 0.5. Now 1 minus 1 is 0 squared, which is 0 times 0.25. This is going to give me 0. And for this one, this x is 2 minus, the mean for this particular situation, times the probability related to that x, which is 0.25. So 2 minus 1 is going to be 1. 1 squared is 1, so this is going to be 0.25. So that means when I add this column, we got 1, and when I add this column, we're going to get the variance. So what we know is with the probability distribution, this is what always happens. For probability distribution, these things are numerical. This thing will always add to 1 because the sum of the probabilities is equal to 1. That's always going to be true if it's a probability distribution. Now, the sum of this one is going to be the mean because this is the sum of all x times p of x. And the sum of this is going to be our variance. So the addition of these things, so your variance is going to be 0.25 plus 0 plus 0.25, which is going to be equal to 0.5 girls. Now we know that the variance is the square of the unit, so this is going to be girls squared. Now when we take the square root, this is just going to become girls again. So this is going to be equal to 0.5. Now, in order to find the standard deviation, what I have to do is I have to take the square root of the variance. So I have to take the square root of, this particular thing, which is right here. So I have to take the square root of 0.5, and this is going to give me the standard deviation for, which this is going to be equal to 0.7. All right. So now I can formally do this. So what I know is I know the mean is equal to 1 girl. The variance is equal to 0.5 girls squared. And then your standard deviation is going to be equal to 0.7 girls. Now, using the rule of thumb to figure out what values represent significantly high and significantly low, what we do is we take our mean, which is our middle value, and then we add and subtract 2 standard deviations. So we know that significantly low is going to be your mean minus 2 standard deviations, and then significantly high is going to be equal to your mean plus 2 standard deviations. So finding this is going to be equal to 1 minus 2 times 0.7, and this is going to be equal to 1 plus 2 times 0.7, which is going to give us negative 0.4 girls, negative, all the way to 2.4 girls. So what this tells us is that the expected value is going to be 1 girls, but that's going to be the most common thing to happen. But what we do know is that we see families with 0 girls, 1 girl, and 2 girls all the time, and that's because 95% of the time, the range of the values is going to run from negative 0.4 to 2.4. So we can see that all the values of 0, 1, and 2 actually live in this 95% of the data value range. So that's why those are not expected. So for finding the mean, the standard deviation, and the usual values for a probability distribution. Again, please consider liking, subscribing, and sharing. Thank you.